Alright, this video is going to be a video about our Pythagorean theorem and how we actually use the theorem to find the side lengths of our right triangles. So let's recall what we know about Pythagorean theorem, and this is important to remember that Pythagorean theorem can only be used with our right triangle. So let's take a look. Our Pythagorean theorem states that we have our legs of the triangle, and you know that your legs of the triangle form the right angle, and then the side opposite of the right angle, which we call C in the formula, is the hypotenuse. So what your Pythagorean theorem states is that if we add the two legs together, we have to square them first and then add them together. That will equal our hypotenuse also squared. So let's take our formula and let's look at a couple of right triangles. If we look down here, we see that we have our right angle here. Alright, so that means these are our legs, so we can label this one our A and we'll label this one our B. So this then is our C, because this is our hypotenuse, remember, opposite of the 90-degree angle. So we're going to rewrite our formula, and then we're going to take the A, B, and C out, and we are going to put what they are. So we're actually going to sub in. So our A squared is what we're going to find. Our B squared is our 6, and our hypotenuse of 9 will be our 9 squared. So then let's go ahead and square those out. We get our 6 squared of 36 and our 9 squared of 81. And now we're going to start solving for our x. So the first thing we need to do is get it by itself. So our 36 needs to be moved to the other side as a negative 36. So that would leave us with x squared over here equal to 45. And remember, how do we go from an x squared to an x? Remember, we take that square root. Now, we talked about taking positives and negatives of square roots. In this case, we are talking about a length, so we will only take the positive square root in this case. So only taking the positive square root, we get the square root of 45. Now, at this point then, we would want to simplify our radical if possible. And in this case, we can go a little bit further and simplify it down, but we will save this. We will come back to this and work that in class. Let's take a look at our second triangle over here. I'm going to cross that x out because really the length of this side is 5. So let's see what we have. I'm going to focus on that right angle here. Sorry. And that right angle is made up of these two sides. Okay, so these now we can say that this is our A, and this is our B, and this is our C, which is our hypotenuse. So let's go ahead and substitute in over here. So we have our A squared, which is the x squared that we're trying to find. Our B squared is the 4. And our C, or remember what that's called, opposite of the right angle, is our hypotenuse. Let's go ahead and square those out. So 4 squared is 16, 5 squared is 25. We're going to solve for the x squared, so we'll move our 16 over as a negative 16. That gives us x squared of 9. Now let's take that square root to get, because we know those cancel out, and we get something a little bit different here, don't we? The square root of 9, we actually know to be 3. Alright, I want you to go down to the 4 problems below, and I want you to work those and bring those back to class. Next thing we're going to look at is what we call Pythagorean triples. Pythagorean triples are wonderful tools for us to have because they can be a shortcut for us when we are working with right triangles. What's unique about Pythagorean triples is that It is a set of 3 non-zero whole numbers, that being our a, b, and c, that satisfy our equation. So for example, do these numbers look familiar to you right now, that 3, 4, 5? I'm going to go back to our previous slide, and I want you to come over here and look at this second equation. Our leg here was 4, our hypotenuse was 5, and you notice what our x was 3? I'm going to come back in here and I'm going to put that 3 in there. Try again. And you notice that we have a 3, 4, 5. And when we came down here to take that square root, we ended up with x equal to 3, which is our whole number. This is an example of a Pythagorean triple. I'm going to go back to the next slide. Some other triples that you will come across. Another one that you see often is the 5, 12, and 13 triple. There are a couple more listed in your book in Chapter 5, Section 7 that you might want to go look at to familiarize yourself with. So I'm going to end here, and what I want you to do then is, after you finish the first 4 problems on the front page, I want you to finish 5 and 6 on this page. And what you're going to do is you're going to find your missing sides over here. So in this case, you're going to find your hypotenuse, because that's the missing side, right, across from the right angle. And then over here, if we look at our right angle, our missing side right here is a leg. And so you will be finding A over here. Once you find these side lengths, then you're going to decide, are they a Pythagorean triple? So think back to that second example I gave you. To be a Pythagorean triple, when you take the square root, you must end up with a whole number. Alright, so good luck. Bring these back with you to class and we'll see how you did.